Hello, everyone, and welcome. My name is Monica. I'm a developer advocate here at Starburst, and today we are going to talk about one of my favorite topics, which is doing SQL transformations on Trino and utilizing Trino as sort of the basis for your data transformations. I have a couple of housekeeping items before we get started. I think the first thing I want to say is this is a hands-on lab, so I'm going to do a little bit of talking at the beginning, and then we're going to jump right into it and we're going to get hands-on and we are going to do some data transformations. And with that, that means that there is a lab guide associated with the presentation today. So I emailed out to anyone who was registered yesterday. The lab guide came from Monica Miller. If you don't have it, that's totally fine. The lab guide is available in the Docs tab. I guess I should have kept my tab open to show you, but it's available in the Docs tab next to here in the chat. And there is a lab guide, and that lab guide will have all of the instructions for getting you up and running with Starburst Galaxy, which is where we're going to be doing our lab today. I would suggest doing that while I talk because it does take a couple of seconds to get registered. And then also the other link that I have associated in the chat is this GitHub gist link where I have already typed out all of the commands for you that we'll be running in the lab today, just so it's a little bit easier for copy paste. We've gotten a lot of great feedback from people saying that sometimes it's hard to keep up because they're copying from the lab guide. So here is another way for it to make it easy so that you can just copy paste from here. So I've put that link in the chat as well. So again, just kind of reiterating, if you're joining us now, my name is Monica, and this is one of my favorite topics today. So I'm very excited to be here with you to talk about doing SQL-based data transformations, building out data pipelines with SQL, and especially using Trino. Of course, I'm biased thinking that Trino is the best engine out there. I, of course, am a huge Trino fangirl working at Starburst, the Trino company. So again, just wanted to reiterate, there are a couple of things that we'll get started. We have our wonderful lab guide that will be associated with most of this presentation. I also have some friends in the chat, so if you have any questions throughout any of this presentation, please go ahead and shout them out. We will do our best to get them all answered, and if they aren't, we will make sure to answer them accordingly after. Okay, so with that, we have a lot of information to get through today, so I'd like to end earlier than later. So what I'm going to do is go ahead and get started. Let's jump in and talk a little bit about transformations with Trino. So I'm going to go back to the slideshow. Okay, so one more reminder that if you're looking to go ahead and get hands-on with me today, go ahead and sign up for Starburst Galaxy while I'm talking so that you're able to jump into the lab guide. We will not be doing that part of the process while we're starting the lab. So I think it starts on page 8 is where we'll begin. Page 1 through 8 is basically getting you logged on with Starburst Galaxy. So if you want to do the lab with me later, go ahead and get signed up for that. And if you also just want to watch today, you'll have the lab guide access for a week. So the passwords that are in the lab guide will be available until 7/31. So maybe you just want to watch today. You will have time to work that lab on your own. And if you have any questions, just send me an email. Okay, so let's go ahead and jump in. Here we are talking about the history of Trino, talking about Trino as the data transformation engine. So I think it's best to kind of just level set and start with why Trino was even created in the first place. And so, around the 2000s, we had that data generation where lots of data was being created, specifically because of the rise of the internet. You had a lot of these large volumes of data, and it was hard to query this data. It was difficult, time consuming, and a lot of people were struggling with this new big data era. And so in 2006, we had Hadoop creation, which was essentially where we had Hadoop be created to meet that need of the large data set. So instead of, dealing with those data sets that previously were unimaginably scale-wise, we now have a tool to actually run any sort of queries and transformations, basically utilize that big data that we previously weren't before. And then in 2008, we actually have some more information where we have that Facebook created Hive to actually query terabytes of data in Hadoop using SQL. So data consumers were actually pretty limited by the number of queries that they could run at Facebook. They could only run 10 a day. I mean, we're going to run 10 queries in the lab very quickly. So if, we couldn't run 10 queries, we would absolutely be out of luck. So essentially, what we have is a situation where Facebook has tried to create Hive specifically for SQL based, commands. So they had a big audience of people who wanted to be able to utilize Hadoop, the data and the big data, but Hadoop was a little bit too complex for them. So that's why the origination of Hive came about. So I want you to focus on that. We'll talk back on that in a minute. So then in 2012, we have a new query engine that was actually created. This was called Presto at the time, now known as Trino. And it was created by Martine, Dane, David, and Eric at Facebook. You can see their wonderful little picture over in the right side. And so essentially their whole goal was to replace Hive. And they started this by creating a query engine that was distributed, could separate compute from storage. And the whole goal was to change what we saw in the past. They wanted something super fast and performant. So that's really the difference of changing between, the past where we had these Hive queries where it took a long time to run, but we want something that is now fast, performant, where they can get their queries in. And the most important thing to kind of echo in on as we're talking about our data transformations today is that Trino is SQL based. So essentially what that means is that you can do, the ANSI SQL base on anything. So Trino is not forcing any of its users to do obscure functions that they may not know. It's really just basing it on that SQL lingua franca that we all know and love, and that is so familiar with people in the data space. And it's just a really interesting thing to note because they even developed Hive for that SQL language originally. Now they flipped over, Trino being SQL based as well. And so before we move on from this history of Trino, just want to talk about, Trino was originally used at Facebook for these interactive queries. And it was specifically built again for Hive, but then they started creating through the service provider interface, the SPI layer. They were actually able to create multiple different connectors, which had them reach into different data sources as well. So now it's become this interactive analytics engine originally built for, that petabyte scale data lake or data lake analytics. It can now do in addition to that, it can also do interactive analytics from multiple different databases. So it can join data from MySQL, it can join data from Hive, it can join data from Cassandra, it can join data from all of these different locations using that one language of SQL, which is so powerful because, each database has their own little flavor of SQL. So being able to sort of level set and have that ANSI SQL base where you can have data analysts, data engineers alike go in and access data no matter where it lived is super powerful. So don't want to undersell that. Okay, I need to go faster. So history of Trino ETL processing. So Martine Traverso did an awesome talk on this last year at Data Nova. I'm just pulling out the highlights here. You can see the source for this event at the top of the slide deck, where essentially the history of Trino is that we had these purely interactive use cases at Facebook, and then it became this query engine that's actually used for multiple different workloads, including ETL. So in 2013, Trino was released into production at Facebook, specifically for those ad hoc and interactive use cases that we talked about, joining data as it could, and then running those petabyte scale queries at, the big scale. From 2014, we actually see users start, well, I didn't see, Martine saw users start to schedule batch and ETL queries with Trino instead of using Hive, which is the big shift from just utilizing Trino from interactive to actually utilizing it as an ETL engine. And then in 2018 at Facebook, Martine said that over 50% of the existing ETL workloads were actually on Trino, and 85% of the new workloads were being created on Trino, which is huge. And so let's think about it. The concept of why the Trino is being utilized for ETL is one, because it's faster and cheaper than Hive. Two, it's that single query language for both interactive and batch. So you're not forcing users to do multiple different tools and technologies. They can utilize the same one for different workloads. And then, of course, the highlight of being ANSI SQL based. So not only was this at Facebook, this also started happening at Salesforce and Lyft, where multiple different companies started utilizing Trino for both batch and ETL capabilities, and also their ad hoc and interactive analytics. I have a bunch of links, as well as the ones on this slide later in the presentation, the resources that share out with other stories from other companies. So go ahead and, if you're interested, keep looking into sort of where other companies have found success using Trino as an ETL engine. So I just wanted to highlight a couple of the challenges with the original architecture. If you've been to any of my webinars before, you know that I am a realist and I'm going to keep it straight with you. So essentially what happened is the way Trino was architecture, it is a massively parallel processing architecture with the goal of being fast. So originally the architecture was specifically built so that it could have that fast processing, meaning that tasks were interconnected and resulting in sort of an all or nothing query result. And from that, what does that mean? It means there were two issues, and potentially, two main issues that people were struggling with, such as memory constraint issues, where if you have your data set get too big, you have too much capacity, you're going to have to scale up your cluster, because if not, the query will fail. And that really, comes with a cost prohibition. So, you have an, you have to really balance that cost versus the speed, performance, and capabilities. So that was an issue that people had. And then also there were some wasted resources upon query failure, which potentially made other queries fail. So you'd have to wait for the query to run completely successfully. Even if it failed 2/3 of the way through, there would still be a failure and you'd have to start the query all over again. Where that becomes a problem is when you have multiple queries being run, and then you're trying to have queries in line, wait for that process, and then the query would just fail and you still have to wait. You didn't get any of the work done in that time period. So that seems to be one of the issues that people had with the original massively parallel processing architecture. Keep in mind, this was just a very small percentage of people, but it was a challenge that they were seeing in the community. So what did the Trino community do in 2022? They introduced fault tolerant execution mode, which re-architected Trino at its core so that it introduced specifically buffers to store intermediate data from tasks. So instead of having one single task fail and you have to rerun the entire query, now you can actually restart at each level. So we have this exchange buffer, which can actually restart a single task, and then you can keep the query progress on and on and on, as opposed to waiting and restarting and basically scaling up and, dealing with that cost versus performance trade-off. So what this does is it actually reduces some of the wasted computation that you may have in case of failures, like we talked about, but it also reduces, sort of end-to-end latency for scheduled jobs. So instead of a scheduled job being forced to wait in line, you can have some confidence that that scheduled job will proceed as expected, because you'll have those SLAs or SLOs be hit as opposed to just making them restart. And then you'll also have that trade-off memory for execution time. So instead of having it all be in memory, you'll have a little bit slower of an execution time, but you'll be able to have the guarantee of those queries finishing. So we like to recommend, depending on your queries that you may run, you really want to evaluate if you need that extra execution time. If you're looking for those heavy load ETL queries, that is something that we would advise keeping in mind. Maybe you don't need them as fast as you may think. You would rather have the guarantee of completing all of your tasks. There's a lot more information on this. Again, the Trino community has done a fantastic job documenting and explaining all of the specific fault tolerant execution updates they've done. I've got links on this slide, as well as in the back, specifically dedicated only to the fault tolerant execution change in Trino. So now I just want to touch on sort of the history of SQL transformations because, like I mentioned, I tried to really nail into the ground that Hive was created because people wanted to use SQL. That was specifically something, that reducing that barrier to entry for people in the data community. You wanted to get as many people utilizing the data as possible. And how do you do that? You do that by adopting the standard that is available today, or even, 10 years ago, 20 years ago when Hive was created, adopting that standard that the most amount of people can use. And so that sort of marks the origin, or even before that, there are many, many, many other tools that have been used for data transformations. Lots of them are SQL based for ease of use. And so this is just a small information of, or a small gathering of all the different types of data transformation tools that you can utilize that are all have some sort of SQL base, as opposed to really requiring that heavy duty transformation with Java, Scala, or Python. And one of the most popular that people are encountering today and every day is the SQL-based data transformation tool, also known as dbt. I have been a dbt user in the past. I'm a very big fan of dbt. I think that's pretty apparent from where I stand, doing a lot of webinars and writing blogs about dbt and Trino together. Essentially, dbt has been this, SQL-based data transformation tool that has taken off in this new age of the modern data stack. They have over 65,000 people in their Slack community, and they're all interested in that SQL-first transformation workflow, which again is just going forward with the basic knowledge that you can use SQL as your main transformation language when you're doing all of your, data transformations. So from your dbt viewpoint, I was able to pull dbt, did this fantastic presentation at Data Nova last year. And so I grabbed the specific dbt slide that they had that I thought was really impactful. And I wanted to nail down the 2 points to focus on here, which is unite on SQL and then work like engineers. And unite on SQL is huge. Like, I think that's where the conversation starts to become is what language do you want to utilize for your transformations? Would you rather use something that can be read and understood by everyone, or would you rather make it something that is difficult and it doesn't really, reduce that barrier to entry? So I love that principle. And then of course, work like engineers. dbt has taken off because of its ability for modularity approaching to building pipelines, applying that software principles to the data. And then of course, we've talked about the SQL already. So, as I was preparing for this webinar, I asked the question, why do you need SQL to actually become a data engineer? Do you have to know SQL? And I got this awesome response, which is here available on the screen today, where we have an AI bot saying, no, it's not possible at all. And then 2 users actually sharing their experience where you have, you really need SQL at the bare minimum. You can still do your data manipulations with other languages. However, it's something that becomes a little bit more difficult. But even if you use all of those different data manipulation tools, you still need SQL as your underlying, knowledge base. And I just thought that was really interesting. We can maybe do data engineering without knowing Python or Scala, but you really can't do any sort of data engineering without knowing SQL. And that's why you've seen all of this possibility of these companies anchoring on these SQL first technologies, specifically dbt, also, Starburst and Trino, because of the ANSI SQL anchoring with Trino choosing that as the language of choice. So I just thought this was really interesting. The responses are hysterical. If you have a minute, go ahead and take a look. And so we couldn't have this webinar without addressing this concept of talking about Spark versus Trino. I found this article by Tomer Ben David. It is fantastic. It's a really unbiased take of the sort of comparison between Trino and Spark. And I just absolutely loved it. I read it multiple times and then I reread it this morning and I was like, am I hyping this up too much? No, the article is really, really good. And essentially what I wanted to give here is sort of my take of what I've seen as a developer advocate now, previously as a data engineer. I have seen a lot of companies utilize both Spark and Trino. The goal needs to be shifting that question to what language do you want to use for the job at hand? What is the use case? Who is accessing the data? How are they doing so? And what is the goal of the assignment, quote unquote? If you're using those heavy processing machine learning algorithms, you need different things that maybe only Python can offer you, then maybe you should be looking at utilizing Spark for that specific workload. However, if you're going to do anything with Trino with SQL, then I think Trino can handle it. And we have a very comprehensive information of all of the different, documentation for transformations that you can do specifically utilizing Trino. And I just think that if you are specifically looking at using SQL, then Trino can absolutely be your engine of choice. With the Medium post, they actually go into specifically talking about, fault tolerant execution mode and ETL. And I don't think this person has picked up on the fault tolerant execution mode re-architecting in Trino. But other than that, I thought it was a really fantastic article. So with the known re-architecture of Trino, introducing that fault tolerant execution mode, if you're going to utilize SQL, then I really think that you should be looking at using Trino in your day-to-day pipelines. There's also the big conversation trade-off of, obviously people utilizing both. There's a reference slide in the back of the deck that shows 7 bridges, which uses both Spark and Trino for their data transformations. Like I said, there are companies that we see utilizing both. But if you can have that 80% coverage, just building SQL data transformation pipelines, as we can see with companies with Salesforce, with Lyft, with Covey, with all of these big companies, all of the companies that are utilizing dbt, then that's something that you might consider as opposed to just, utilizing Spark. Because with Trino's fault tolerant execution mode, you kind of have those capabilities at least leveled a little bit. So that's just something to consider. I just, there is this big myth that you can't do any sort of transformations with Trino and that it's actually just for interactive. And that's what we're going to do today is completely bust that myth with our lab, where we're going to do a completely SQL-based lab and go through all of the different instructions. So this was just kind of the questions that I would consider asking when figuring out whether to use Spark or Trino. So here's one of the architectures we see a lot is with Trino and dbt together. And so I just wanted to kind of show you what that would look like. So it would be having your incoming sources on the left-hand side. You'd use one of your engines for ingestion, Fivetran, Airbyte, whatever you want, Kafka, Starburst choice, whatever choice you have. And then you would build within your data lakehouse architecture of sort of your first layer, which is your raw layer, your bronze layer, build sort of a medallion architecture. And then you'd use dbt and Starburst to do some data transformations, pull in your silver layer, your second layer, basically clean and optimize all of your data, utilize dbt and Starburst again to build for your final data consumers in the gold layer. And so essentially it's just about bringing in that modularity component that dbt has. We see a lot of people using dbt and Starburst together, dbt as the specific SQL transformation modularity component, and then Starburst as the query engine, because dbt does need a query engine partnered with it to actually run any of the data transformations. So we see a lot of people utilizing this not only in object storage, but object storage is the main place that we see it. Actually, we have one example here with Yellow where they're utilizing Trino, dbt, Iceberg, and S3 on their data lake to just do all of their data transformations. I've attached the reference here. They gave a great talk at Data Universe earlier this year where they talked about re-architecting all of their data platform to utilize Trino for their data transformations. And so I thought this was a really interesting talk to bring up here in case you wanted to look at the real world example as opposed to me just giving you a sample architecture. And this was kind of just a slide to be a little bit more realistic and show you, again, we have those multiple data sources coming in. but it's acknowledging that you don't just need, Trino cannot potentially be, Trino doesn't have to be that query engine of choice. You can still build this data architecture with multiple different, query engines or different, compute power. But the big advantage that you have when you're positioning Trino is the ability to do those SQL first transformations. And I don't think that can be undersold. I think that just makes your life as a data engineer so much easier. I admittedly was a data engineer for about 3 years, and I primarily worked in SQL. We did SQL transformations. I did ETL pipelining. I did a small bit of dashboarding. I did a lot of bash scripting, scheduling, and all of my main language was SQL. And I'm so grateful for that experience because it now lets me stand up here and talk to you today and be really genuine about it. I do think that SQL is one of the best engines for the transformations, and it can really reduce a lot of the complexity and get you answers to your data faster, which is exactly what we need. So with that, we're going to jump into our lab architecture. I think we are right on time. So we are going to get about an hour for this lab. It's going to be a really, really awesome lab. And what we're going to be doing is building out that SQL data transformation pipeline. We're going to be using some data that lives in our data lake, and then we're going to be cleaning, optimizing that data in our data lake architecture, as you saw with yellow, as you saw with sort of that reference architecture above. We are going to be changing our table from a Hive to Iceberg table because we do think at Starburst, not only do we think that Trino is the best engine, we also think that if you have a choice, you should use Iceberg as your table format of choice. So we'll get to play a little bit with Iceberg and see a little bit of sort of the capabilities you can have in the data lake. With the components of AWS, Iceberg, Trino, and that SQL data transformation, you've basically built out an architecture that we see a lot in the field. We won't be adding DBT to this today. That will just be something for you to consider. But we have a couple of other upcoming webinars or potential webinars or past webinars we can send you that incorporate using Trino, DBT, and the data lake. So can give you that next level if you potentially want to look into that deeper. But we'll be able to do a lot of the just transformation based with Trino using Starburst Galaxy. The only thing that you would want with DBT is actually breaking it up into sort of that modularity components and then actually building out a full scale pipeline. We'll be doing that. It will just be a manual pipeline as opposed to scheduling all of it with our favorite, scheduling tool of, Airflow, Dagster, whatever you choose. Okay, so with that, I just wanted to show you the 2 quick resources page. This is some of the companies who use Trino for ETL, engineers who have created the Trino for ETL and re-architected it. A lot of the information, the Reddit post, the LinkedIn post, the Medium posts. So basically a wide range of information for you that you can get and gather from people who actually worked on the fault tolerant execution re-architecture to people who are actually utilizing it every single day. And then, of course, I just have this slide talking about the resources with DBT and Trino because it is something that comes up a lot when we talk about SQL transformations. And then transparently, I wanted to show you this last architecture that I talked about, the 7 bridges architecture, where they are using Trino and Spark for different, they have their heavier ML use cases using Spark, and then all of their analytics they are using Galaxy and DBT. So just wanted to call that out and be fair because that is something that I'm very passionate about, is making sure I present to you everything that I know and kind of where I'm at. So with that, I am going to jump into the data lab and we are going to get started with building our pipeline. So we have our ETL Mythbusters lab. I've sent out the PDF. The PDF is in the docs available to you. I also want to call it again, there is the gist so that you don't have to copy paste everything. This will actually have all of these SQL commands that we're going to be running. So it's a little bit quicker. And so with that, I am going to pull over the lab guide and I am going to get started with running the lab. So let me just get my screen situated. Hopefully you can still see, and I'm just going to copy that over. And we are going to get jumped in. Okay. Appreciate you giving me a minute to get situated. And I think we are ready to roll. Okay, let's get started. And with that, I'm going to actually pull over the lab guide and we're going to look at it together for a minute. Let me zoom in. So our purpose of this lab is to, one, build that ETL data pipeline using SQL, but we're going to be actually answering some questions regarding the Blue Bikes Boston data, which is a bike sharing program that is in Boston. We'll be looking specifically at the transactional records that come from the bike trips. So we'll be able to look at the start time, the end time, the trip distance, the average, trip, all of the different information that comes with these bike rides. It'll be really interesting. We'll have all of the data be imported from or ingested, and then we'll build it out in the data lake as well. And then we'll have a reference table for basically some postal codes that we'll need to join our data together with. So before we do that, let's start by looking at sort of our data pipeline and the layers that we need. The first layer being the bronze layer. This is going to be where we're ingesting the data for the bikes. So we're going to have a new data set that will land in our raw data working table. And then this bronze layer will essentially define the location for the historical raw data. And then new data will be landed there. Somehow you'll get a trigger to pick it up, and then you will move that data into the ingestion. So in a traditional data pipeline, you would have some sort of orchestration method associated with it that would know that this data is loaded every month as opposed to being loaded every, week. So then it would pick up that data every month when it was scheduled and move it forward through to the silver layer. So in our silver layer, we're going to actually transform that data that lives in the bronze layer. So we're going to ensure its data quality. We're going to transform the data into the proper data types. And we're going to also do some analysis and augmentation to the data based off of what we need to evaluate. Specifically, we're going to mess with the postal code a little bit. Then our gold layer, we're going to actually build two different views that were requested by our downstream consumers. They are going to be views that calculate the minimum, the maximum, and the average duration for starting station. And then we will also build a view that kind of calculates the average income based on the rider postal code. So with that, let's kind of look at where this initial data set is landing. You can see here we'll have our raw data living in sort of our Blue Bikes bucket. And this is where that data will land. And then we'll have we'll fake scheduling the process out. If we were building the full pipeline, we would actually incorporate that schedule part, but we'll just touch on that today as opposed to doing the scheduling as well. So here is what that data lake looks like. We have all the different files from 2022 January to 2022 September. And our goal will be to get all the way up to 2022 November. So we'll actually do 3 different ingests to pull that data in and sort of do a historical load and then do 2 different incremental loads to update our data. So here is sort of the information that you would see in that data place here so that you don't have to go looking for it. And this is kind of what would be a record standard in that data. You can also find it on the Blue Bikes information, but just wanted to give that out here. And then now we're at the getting to the Starburst Galaxy account. So I'm going to skip through this. This is something that we'll expect you to do on your own time. The last point is just this housekeeping data of if you want to watch along and then work the lab after, you have until July 31st. If you need more time or need anything else, go ahead and email me. I'm happy to help there. Okay, so let's go ahead and get started. I'm going to jump into my Galaxy account. I am going to get started by just first connecting to my data source. So let me go ahead and get the lab situated. And we are going to start on page 10, where we're going to just connect to our AWS S3 catalog. So I've logged into my Starburst Galaxy account. I've gone to the data catalogs page, and the next thing I want to do is hit that create catalog button. So I'm going to click Amazon S3, and I'm just going to provide a name and description so that I can get the information that I need. I'm going to put just the Blue Bikes catalog, and I'm going to also add that I want to just put the description as a Boston bike sharing program. So I'm going to type that over here. And now I'm going to copy paste the authentication mode to S3. So I'm going to use the AWS access key. You can also use the IAM role. And essentially, I see this question in the chat really briefly. Sorry, I'm trying to keep my eyes on the chat, but also trying to make sure I maintain time. But I do see a question about more details for different catalogs in Starburst. So I'm going to actually exit out and show you really quickly. Catalogs are utilized to connect to different data sources. So you can connect to your object storage data sources as shown here, S3, ALDS, GCS, but then we also have all these other additional data sources that you can connect to, and then you can join your data together. So the way that Trino is created, if you want to know more about Trino and Starburst, we have a Starburst 101 coming up next August, or coming up in August, where we can give you basically a lab on and background on Trino and Starburst and how it works. But essentially, these catalogs create the connection to your data sources so that you can have your clusters, which power the compute, and essentially get the connection to that data source. So just wanted to pause there. I'll go ahead and restart now, where I put the Blue Bikes information in, and I'm going to put in the description. And then I'm also going to select the access key, where I am going to pull in just the access key that I see on my lab guide. Again, you can connect with two different methods. It just depends on your need for the organization. We'd probably recommend doing the cross-account IAM role, but for the access key, it works perfectly for our lab's purpose here today. For our Metastore configuration, you have three different options. You can use Starburst Galaxy, which is the default. You can use Glue, or you can use your own Hive Metastore. We're just going to use Galaxy for today for the ease of use. And then we're also going to specifically click on the bucket name that we need, which is going to be the Starburst 101 hands-on lab. From there, we're going to add the default directory name, which is ETL Monica Miller. So what that is going to be is it's going to be your name of the prefix, and then with the prefix ETL, that will just help me for cleanup purposes. And then you can go ahead and type your name inside so that I know that it's been something that you participated in the lab, and we're going to, clean it up later. So that is sort of your default directory name. All of your data will live in there as we build throughout the lab. We're also going to allow creating two external tables and allow writing two external tables. And that way we can actually build our full data pipeline. And I'm going to hit that test connection button, and I'm going to hit connect catalog. So we've got our first catalog created, our only catalog of the day, where we're going to be connecting to that data lake so that we can build our full pipeline in that data lake. You'll have a screen pop up that says set permissions. What you're going to do is just click save access controls. That's just giving you account admin permissions for the catalog that you just set. And I just saw a really great question in the chat. Starburst Galaxy Metastore, if it uses Iceberg, it can be used for Iceberg or other different, it can also be used with Delta Lake or Hive or Hootie if you're only doing read only. But the really intuitive part of that question is that we have built a lot of our specific systems in Iceberg. So I wouldn't be surprised if Starburst Galaxy, if the Metastore internally uses Iceberg. That's what my bet would be. I can follow up on that and get you a full answer. Okay, as far as attaching to the cluster, we have our clusters available to us. We have the free cluster, which should be available. This is a cluster I've previously created. So go ahead and just select that free cluster, which will have the information for specifically the, specific compute power that you'll need for the workload. So I'm going to select that free cluster, and then I'm going to hit add to cluster. And I'm just going to click right now. It's going to ask if I want to run schema discovery. I'm going to click do this later. And what I'm going to do now is take you on a little journey. We're going to stop with the lab guide, and I'm going to show you the cluster configurations. I thought that this was something I could just do on my own without making you basically update the cluster. So go ahead and take a quick pause and let's look at our cluster configurations available to us. So you can see here, we've got our clusters and we can actually look at the different clusters and their execution modes. So let's say I have my cluster name. Obviously, I've got the catalogs I've selected. You can see the Blue Bikes one that we just connected to here. You can have your region, which can essentially, your base region for all of your catalogs together. I am using a free cluster, so that's why I can't connect to multi-cloud or multi-region. If you want to do multi-cloud or multi-region, that's just something you have to actually pay for and get set up. If you have any questions on that, I'm very happy to help there as well. Here's what I really wanted to call out is here we go, proof that it's live. Let me go ahead and sign in. Okay, let me go ahead and get in here. If I want to go back to my clusters, I can see here that I have different cluster options. I can choose the small, medium, large. Basically, what this is showing you is that you can actually tailor your cluster size to the workload that you may need, which is a very important part, as we've talked about in Trino earlier, and something that you need to do basically with Starburst as well. But Galaxy has a lot of tools to help you do that a lot easier than you may have to in Trino, because in Trino, one of the main issues is that performance tuning. We also have different execution modes, and this is what I really wanted to call out is essentially all of the work that they've done in Trino. What we've done for Starburst is actually expand on that fault tolerant execution mode work, and we've made it even bigger so that you can go up to a lot more terabytes than potentially you had in Trino. But we have this fault tolerant execution mode specifically for optimizing those resource intensive queries. Because of our lab today, I want to keep everything free so that anyone can utilize it, not just people who have created accounts within the last 30 days. You can choose to either use the standard mode or use the fault tolerant execution mode. Either or is available. I'm going to stick with the standard just so that if anyone watching this after sees, they know that they can do this lab with the standard mode and with the free cluster. I just also want to show you the customized auto scale that you can do between your min and max workers. There's a lot of really powerful things that Starburst Galaxy does to make the management of Trino easier. And I love them because they make my life easier too. So I'm going to click free and I'm going to just hit cancel because there were no changes. And I am going to resume my cluster so that it is ready to go. Okay, so with that, I'm going to navigate back to the query editor. And you can see here that I now have my Blue Bikes catalog connected. And if we open it up, we see that nothing has been added yet. So we're going to need to add some data in. And in order to do that, we need to set a location permission so that we can actually access the data in the location that it says in the lab. So if we navigate to page 15, you can see that we are going to be granting location-based access control so that we can access the data from the Blue Bikes data that lives in our bucket in S3. So I am going to navigate to the Access tab, and I'm going to go down to the Roles and Privileges tab. You can see here you can create different roles, different privileges, all the information that you may need. And what I'm going to do is actually click on the Account Admin button, and I'm going to go to the Privileges tab. And you can see here, you can assign privileges based off of a wide variety of granularity. And we're actually going to use location in this instance. So I'm going to hit Add Privilege, and I'm going to click on the Location button. And now what I'm going to do is paste the storage location name that's available on page 16. I'm going to copy that over so that I'll have access to all of the data that lives within the Blue Bikes realm. And this is really important. We need to make sure down here what type of access should be allowed. You need to click the button that says Create Schema and Table Location. That will allow you to then actually read and do the analysis on the data that lives in this location. So with that, you can click Save Privileges. And we are now all set up. So Starburst Galaxy actually utilizes a combination of role-based access control and attribute-based access control to really give you a very fine-tuned granularity of, data governance and access and security. So something that we have other labs on. If you have any questions about that, go ahead and let us know. So now we are moving on to the meat of the lab on page 17. We are going to actually be building within our data lake. So we're going to do our full data pipeline utilizing our data lake. We'll use Iceberg, Trino, we'll use S3, we'll use all of the things that we need. And of course, we'll use SQL for all of our transformations. So I am going to navigate to the query editor. And I am going to start by creating a new tab if I don't have one, but I have one tab, so I'm good to go. And the first thing I need to do is create a schema for all of my tables to live for this lab. So what I'm going to do is copy over the create schema statement that lives on page 17, and I am going to paste it in the query editor. Now, if you'll notice, there is a specific change here. We need to delete the your name position after the blue bikes catalog, and we'll need to update that with our schema name of choice. Please make this an identifier specific to you. So I am going to do ETL Monica Miller, so that is specifically my schema, and I'll have no overlapping anywhere. Okay, so I need to do underscores. What am I thinking? There we go. Now I'm ready to hit run so that I can actually create that schema. So now that I've got my schema created, I'm just going to kind of verify that on the left-hand side in our Cluster Explorer. We can see a new schema has popped up. There should be no tables in it. We see no content. And to make our lives easier, what I'm going to do is actually select a catalog in a schema up here in the top left, where we can do a shorthand for all of the queries that are in the lab guide, as opposed to having to type out the catalog, the schema, and the table name. So what I'm going to do is select the Blue Bikes catalog. I'm going to select the schema of choice. So I'm going to select ETL Monica Miller. And then now I'm ready to run any of my queries that are in the lab guide. Make sure your cluster says free cluster, as mine does up here. So with that, we can move on to page 18 and we can start building our bronze layer. So the first thing we're going to do is actually create that ingest table in our bronze layer, where we're going to actually temporarily house that raw data coming in from the Blue Bike system. So we're going to actually pull in a specific CSV file, and that means we have to make all of our data types varchar. So this works well for us because we're going to be doing SQL transformations throughout the entire lab. And a lot of times you'll have data that gets dropped potentially as CSVs, and you have to do the manual transformations to them yourself. So this will kind of be aligned with that strategy. I know that when I had a lot of CSVs come in, and then we'd have to transform that data into the proper data type. So this will be sort of an example of that. So with that, I'm going to copy over the create bronze table statement on page 19, where I'm going to copy over the all varchar bronze temp table. And you can see here, it looks like this. We've got our create table statement, our Blue Bikes bronze temp trips, and then we have basically information from that transactional Blue Bikes data, like the trip seconds, the start station ID, start station name, latitude, longitude, and station ID, bike ID, postal code, etc. So it's all the information surrounding those bike trips. We're also going to be utilizing Hive for first, so that we can, because our data is landed at CSV, and then we'll update that to an Iceberg table going forward. Pulling in the information to skip the quote, and then we'll also pull from that external location that we gave permission to earlier in the lab guide. So I'm going to hit run, and we are going to build out that initial bronze temp table. Now I'm just going to run a basic SQL query to validate that that worked as expected, because that's very important. So going to be validating as we go through each of our table creations today. And if we click run, we'll be able to see kind of what that data looks like. Oh, go ahead and let me, I think there was an issue there. See, this is why it's really important to validate. So let me go ahead and drop that table. And then we'll rerun it and hopefully everything will work as expected. I think it was because I had an error in my S3 line. I had a line break, which is why if you're copying with a lab today, probably use the gist so that it's easier. So let's go ahead and hit run. We have that table created, and now I'm going to select from that table and we'll be able to see our data. Okay, so you can see sort of that trip seconds. You can see those start times, the station ID, all of the information that may come. And what we're going to do is clean up these varchars and actually utilize everything going forward to, clean them up to the proper data type and the proper command. Right now, we are not using the Hive catalog. We're using the Starburst Galaxy Metastore, but we're using a Hive table format in AWS. So it's a little confusing, but we are using Hive over Iceberg for this specific table. Yes. And then now what we're going to do is create our second table where we're going to just pull in the information of reference data for our zip code income. So this is just going to be something that we're joining together. This table might be in Postgres, it might be in Redshift. So essentially, right now we're just making it easy using them both in S3. So we didn't have to connect two different catalogs, but this is probably a reference table that might live in another location, potentially Snowflake, Redshift, like I mentioned. So we're going to go to page 21, and we are going to run that second command. So I'm going to copy the zip code income table, and I'm going to paste it in my query editor. And what we're going to have here is just basic zip code information like state, zip, total income amount, average income amount, all of the information loaded up from here. This is also a Hive table just for reference because we're pulling in that text file and that raw data. So we're getting it as it's expected or as it's delivered to us, and then we'll be doing the transformations going forward. So now I'm going to just run a basic select to make sure that that one worked as expected. And we can see here we've got the state, the zip, all of the information on the total income, which is extremely interesting to go through. I got to play with that a little bit this week or last week, and it was very fun to look at all of the different zip code income that may be available to us. So now we're going to actually move on to transforming our data types. If we go to page 22 of the lab guide, you can see that we have a lot of different columns that we need to update. As we mentioned, they came all in as varchars. So we need to basically find the right data types for each of our columns, and then we need to cast them in their new data type when we do our silver table. So we're going to do some interactive analytics here, which is another great reason to use SQL for both, so that you can switch between interactive analytics and you're basically then just harden your transformation pipeline really easily, as opposed to having to create a whole new pipeline when you're trying to, build it out in production. So with that, we're going to evaluate the trip seconds. So we're going to look at the min and max, and we're going to figure out like if those are within bounds or if we need to do any work on that. So I'm just going to run a basic select on page, what page am I at? 22. And we are going to look at the min and max of each trip seconds. Trips. Oops. There we go. And I'm going to hit run. And we'll be able to see the min and max values of each. So we can see we have just our min as 100, our max is 999. So we've got all of the information available to us of like what is our min and our max, and kind of building out, for our transformations, what we need to consider for our case statements, all of that going forward. And then we also want to look specifically at the trip seconds if we can cast it as an int. So we're going to know upgrade from looking at the min and max to actually trying to do that sort of cast information. So if we just run that select statement available on page 22, we can see that we are able to cast it. All of the data looks as expected. We'll now incorporate this into our new insert statement that we build in our silver layer. So now I'm going to copy over the query to look at the specific timestamp values in our bronze layer. So what I'm going to do on page 22 is copy over the query for evaluating trip seconds and start times and end times. And what we want to do is just run and evaluate that we can transform that properly before actually doing it. Again, doing that little interactive flavor before we build out our full pipeline. So you can see here we've got our trip seconds, our start time, our stop time, everything looks like it transformed as expected. So we can add that to our list of transformations we'll do in our silver layer. And now it gets fun. Now we're going to look at the postal code, and we'll actually have to do some updates to that before we start going. So I'm going to copy over the specific statement on page 23 of the lab guide, where we're looking at the min and max postal code. So you can see here, select min postal code, max postal code, and we're going to look at that information and then go forward from there. So if we look at this, we'll get a little bit less of that clean cut result than we might have gotten in the past from all of our different other evaluations. You can see here, we have postal codes that don't exist, so that are null, so that are completely blank. And then we also have postal codes that aren't numbers. So this is going to be a little bit trickier of an evaluation to, sort of build as we go out. We can't just do a cast value. We need to actually do a little bit of transformation when we're building out from our bronze to our silver layer. So now we're going to kind of dive a little bit deeper and figure out what transformation we need to do. So let's look at the count of the postal codes that exist with just the blank space, because I want to investigate more into this null value, and then we'll deal with the numbers, or the letters as opposed to numbers. So let's start with the specific count of just the blank spaces, and let's see what we return. Okay, so we have 3,000 rows records about that have a postal code of just a space, which is interesting. As coming in from that CSV, we're going to need to do some data cleanup so that we actually make that a null value other than just a space. And speaking of that, we should probably look and see how many postal codes are null anyways, right? So let's run the query on page 23 to just look at the postal codes and evaluate if any of them are null. So I'm just running that basic query, and we see that none of them are null, which is weird because we saw when we were doing the min and a max that we had those space unfilled. So we know that there are at least values that aren't sufficed by this. So let's do one more investigation, and let's look at the count specifically where the postal code equals the null as a string. This is something that I used to get tripped up with when I had varchars coming in. It was always make sure we know that the null is being converted from that varchar to an actual no value in my data type. So yeah, here we go. We can see that we have our postal code is actually a value of null. And what we need to do is update that to be, it's a varchar right now, and we need to update it to be an actual value. And so we have over 374,000 values in addition to the 3,000 we have here that we need to transform. And we need to figure out how to do a data transformation with both of those as opposed to just satisfying one of those conditions. So we've done a little bit of the pre-work for you. And on page 23, what we're going to do is grab the select statement available to us, and we're going to pull in a null if replace value. So what this is going to do is it's going to, if it has that null value available here, those 37 records, it's going to replace it with that space. And then if it's got that space, it will create a null value for us. So we're going to run that select statement. And if we go through here, we can now see the data gets output as expected. So you can see that null value up there. We still have a couple of things we need to address with our postal codes, because you can see we have different values. Here are some more nulls, but we've got a big chunk of it taken care of. So now I'm going to move on to page 24 of the lab guide. And what we can see here is we are going to basically enrich the data. So I'm going to, well, let me just show here on page 23. We've collaborated or grabbed all of the different transformations we'll need to do for our data types. You can see we'll be doing the trip seconds as an int. We'll be casting the start and stop times as timestamps. Station ID, latitude, longitude, all of those will be as ints and decimals. So they'll be put into the specific right category. Bike ID will be cast as well. And then we also have these data types, user and station name, start station name, all need to remain varchar, so we leave them as expected. So this is kind of where we're at in consolidating all of our transformations from our bronze to our silver layer. We could run it. It would just come back as expected. So I'm just going to skip forward and go to the next step. And that next step is actually enriching our data, enriching our postal code data with our zip code income. So if we go and look at our zip code table, you can see here, we have some data that we need to look at so that we can pull it in. Specifically, we only have USA zip codes available to pull in the information. So let's go ahead and just run kind of a basic analysis on it and see what comes back. So I'm just going to copy the SQL statement on page 24, and I'm going to run some information on the basic zip codes we have available. So we're looking for the zip code, the state, and we're going to look at the average income for each state. I ran my zip code, which is in Dallas, Texas, and then I ran in California and New York, and we can see that average income is absolutely very different in all three of those areas. I just thought that was really interesting disparity there. And so what I wanted to do now is just sort of incorporate that as we go forward. So, we're now going to pull in that zip code information into our bronze, into our silver table when we do our transformation on the data. Okay, so we've got our data, and now what we want to do is look at two of our Massachusetts zip codes, and we want to validate that those leading zeros aren't going to cause any issues for us. So I'm going to copy from page 25, and I'm going to just run the basic select statement, and I'm looking at these initial zeros. So you can see here as the zip code, it comes back as, for specifically from the zip code income table, it comes back as an integer, which is going to cause an issue for us because we need to make sure we update the integer and the varchar to match. But our varchar has a lot of different information in it. We have our 5-digit zip codes, but then we also have the additional 4 numbers. We also have the specific, Canada postal code. So we need to make sure that we account for all of that in our update. So to sort of expedite that, we're talking about it now, we're accounting for it, and we've got a specific SQL statement that we can utilize to grab all of the zip codes without, and basically do that SQL transformation on the fly as we're building out our silver layer. So I'm going to copy the statement from page 26, and I am going to run that and look at the zip code analysis. So if I go forward here, I'm going to copy the page 26, postal code information, and I'm just going to run it to make sure that we can do it specifically for those two Massachusetts codes that came back different. But you can see we're looking at the postal code, the total income from both the bronze temp trips as well as the zip code income table. And we're casting the postal code to be equal to the zip code. So we can see we have data that comes back as expected, and we've got that 0 involved. So we are good to go going forward. And with that, it is time to build our silver layer. So we've done that initial data transformation level. We've done interactive analytics on our bronze layer. So now we can actually apply that, sort of do our hardened data transformation to our silver layer. And then that would be what would be essentially hardened in production using your favorite orchestration tool. So we're going to build that silver layer by doing a create table statement. And this is going to be replicating a historical load for all of the data that we may have in the past. So I'm going to copy over the statement from page 27 where I create that lab table. And I'm going to paste it in our query editor. And here you can see we have the name of our table, the Silver Trips Blue Bikes table. It is a iceberg table, org format, and we have all of the data transformations that we're going to build out. So I'm going to hit run. This is going to take a second because I am using an absolutely free cluster. So one worker, one coordinator as the same cluster. And then we also have a lot of heavy transformations here. And it's a standard free cluster. So I just am going to, it's going to like take 40 seconds. But if you wanted this to actually be fast as expected, then we need to scale it appropriately for all these hardened transformations. Okay, so here we can see all of the different data types we're casting. You can see the null if statement we're building, where we're going to update the postal code for our T user type. And then we also have the province being cast as a varchar from our zip code. And then you can see our zip code rounding as well as our join to try the zip code, where we specifically integrate, basically we're placing it with null. Then we're also splitting it up. So we're taking out the components that maybe have the last 4 digits, and then we're only left joining. So we're joining the data from the US. That makes sense. If it's Canada, it will just pull in the information. We just won't have the zip code information attached. So that's all the information on our table for our silver table. Everything else will be really fast now. So let's go ahead and run a couple of statements to just get some information on that table. So I'm going to run first a basic select to validate the data loaded as expected. So you can see here we've got our trip information. You can see a couple of the changes maybe in the decimals of like the start station latitude and longitude being longer. You can see sort of the rounding on some of it. And then if we go to the income, you can see that. So you can see sort of some of the transformations that we've applied. We could dive in deeper if you have any questions. And then we also have, the basic count. We just saw 2000-ish. And now we're going to just validate that the silver table has the exact same count. You can also run these using different data quality metrics on your data using Galaxy. If we were to pop open, which I'll do right now, I can pop open the table. And you can see here there's a quality tab. So you can run these basic quality applications for the transformations. And you can do that using the lineage tab as well. So we can see here we've got our BB silver trips created from our bronze temp trips, and we can see that transformation that we just applied. Just something to note as we're going through this lab is keep in mind your lineage checks, and then again your quality, where you could say make sure the postal code, well, that's a bad example. Make sure the maybe the start date or the start timestamp is not null. So you could do something like that. Okay, so let's just look at the stats here and show basically the information we've got. We got all of our columns, all of our distinct values, and our low counts and our high counts. And now what we want to do is actually go forward, and we validated our silver table. Now I just want to run a couple of different iceberg commands to kind of show you how, basically validate our table as an iceberg table, and then get your head thinking about all the different things you can do with iceberg. So I'm going to copy over these 3 commands available on the bottom of page 28, where I'm looking at the specific metadata tables for iceberg, and I'm going to look at the history, the snapshots, and the files table. So first, let's start with the snapshots table. What we're going to have is the one snapshot loading that data that we did from our transformation from the bronze to the silver layer. And you can see the added amount of records here available to us. We can also go look at the history, which will show us that one run where we have the current snapshot available, basically the changes to the table. And then we also have the files available to us right now. You can see all of the information for the file path available, all of our different record counts, files, and size available to us right now. So now what I want to do is kind of validate those zip codes that we had some issues with in the silver table and just make sure that everything's okay. So what I'm going to do is copy over from page 29 in the lab guide. I'm going to copy the specific count for the postal codes, and I want to look at postal codes that actually say null or have that space in them. So let's run and see if those were updated as expected. they were. And that's something that you could also do a quality check on. So you could run, basically a data quality check in Galaxy that says, oh, hey, if there's any nulls specific to match here, you could, return a flag. The other thing I wanted to do was select that count. So we're looking for our 3,000 plus our 37,000 or 374,000. So we can see our total null count actually as 377,000, which is the join of both the postal codes as a space and postal codes as a null. So expected transformation, but just always good to validate. And so now what we're going to do is actually build out our gold layer. So we validated our silver layer. We are ready to build out our gold layer. And so we're going to construct the last of 3 different layers of our sort of data lake reporting structure and our medallion architecture. And then it's going to be the gold layer. So the first ask of us is to build a view that calculates the minimum and the maximum and average duration by starting station, and it's for all different types of users. So there are subscribers and there are customers. Subscribers are people who have that subscription model. Customers, just that one-time user. So we'll look at sort of the average duration between the two and kind of evaluate that. And then we also want to look at the average income based on the writer postal code broken out by month. So that's really important, broken out by month, because we're going to have to do multiple different incremental loads through our data pipeline. We only have through September right now, but our ask is November. So we're going to replicate doing those incremental loads as expected with each month. So we'll need to make sure that the view is updated accordingly as well. So with that, on page 29, I'm going to copy the first SQL query necessary to create the view. So I am going to grab the specific view for the aggregation. I'm going to hit copy and paste. And we are going to look at the aggregation of that start and stop time for each station. So I'm going to hit run. And we'll be able to see the min and the max and all of the different areas in between for our specific user types and our station ID. So I'm just going to select, or I'm going to run a basic select. So we validate that that view comes in as expected. And we can see here we've got our station and we also got our user type. We've got all of the information that we need. And it's interesting to look at the subscriber and the customer. You can see customers actually tend to ride longer, which is kind of interesting because I guess the subscribers are there to get where they need to go and the customers are there to, ride around leisurely. So sort of an interesting analysis there, but you can see the min, the max, and all the different ones for each station. Okay, so we've got our first view created, and the other thing we want to do is showcase that in our specific lineage. So I'm just going to go back to the silver trips, and I'm going to make this my table of anchor table. And you can see here I've got my 2 tables that are being flown into my silver table or being fed into my silver table, and then we can see that one view aggregated from the silver trips that we've created already. And we can see each transformation that we've done throughout our data pipeline, which is super interesting. Okay, navigating back to the query editor, we've validated our first view. So now we are doing our second view. I'm going to go ahead and hit the page. What page is this? We are on page 30. And I'm going to copy that second view to essentially get the month requirement. So I'm going to copy that over and paste that in the query. And we are going to hit run. And we'll be able to now validate that utilizing our select statement. So the important part here is to validate the trip month. We can pick any trip month from our load from January to September. So we're just going to do April for now. But as we do the incremental loads, we'll validate that they are additionally the specific data month as expected. So we've got our trip month, our hour of the day, and the average income for each, which is also an interesting evaluation that our data consumers needed. So we've done our check, and now we've done our historical load, we've built out our views. Now we're going to do our incremental loads. So we are going to first do this a little bit. This is going to be simulated for the lab, so there might be a little bit more information available. If we were doing this in a more cohesive manner, then we would actually schedule the drop table. We'd move the table from one to the other in the S3 location, as opposed to just dropping it. But again, simulated for our lab environment here today. So the first thing I'm going to do is drop that bronze table, the temp table from us, and we are going to then recreate it with our new data. So I'm going to hit run. I'm going to drop that table, and then I'm going to copy over from page 31 the lab guide that has the new external location for our bronze table. So I'm going to copy that over. And you can see here we've got our bronze table. We've got the same data as expected with our data types. And then we're going to copy the external location over. I'm going to hit run. And now when we run our select query, we'll see that all of our data is coming from that October month timeframe, as opposed to, or I guess September, whatever 10 is. August is 8, September is 9, so October is 10. So we're going to copy over, make sure all of our start time matches October. And the other thing I want to do now is just select a count from the bronze trips, just to validate how many came in, how many records are available to us. So I'm just going to run a basic count statement. And we'll see here we had 416 records come in from that 2022 10 location. Okay, and so now we want to do that incremental load for our October data. So I'm going to copy in the insert statement available on page 32, and I'm going to run that, inserting those 416,000 new rows into our table. So I'm going to hit copy and paste. And you can see here all of the data transformations that we've already established are necessary. And I'm going to hit run, and I'll be able to get my data back in a minute. So we've got our rows inserted as expected. And if we go to our silver trips data, we can actually see the transformation history. So we can see the one we just ran, as well as the one we ran about 10 minutes ago. And you can see the different increments of data. So we had 29, or this start with this big number of rows beginning. And then we had our 416 rows that we just inserted, which is so handy, the lineage feature, when you're trying to do any sort of debugging. So I'm very appreciative of it. Okay, so we validated our data. Now we're going to just do a basic count on the table to validate that we've got that additional 416 rows in. You can see our data has changed from those 200, or I guess 2 million, to now we have that additional 3 million. And we're just going to validate the incremental load using our iceberg metadata commands. So I'm going to copy over, and I'm going to look at the files, and I'm going to look at the snapshots. So if I just look at the files, we'll see that they definitely got bigger, adding those extra rows in. And then we can also see that if we look at our snapshots table, we'll see an additional addition to our table there for adding those extra rows. So you can see here we've got our new snapshot that has the addition of the 416 records. So it's basically capturing our table information that we need from all of the history that's changed on the iceberg table. And now I just want to validate the 2 views that were updated. So the views will update automatically based off of the table. That's one of the trade-offs between views and materialized views. But I'm just going to validate that they are growing in number as expected. So I'm going to run the select statement available on page 34. Going to run that count, and we can see that number is 907, which is incrementally greater than the 899 we used to have. So that is expected as we build in more data information going forward. And then the other thing I want to show is the select statement for specifically the average income for month and hour. We want to look at the new trip month that we've incorporated. So we want to validate that we have trip months associated specifically with October, and we do. So that's the great thing, is we have all of this information and average income specifically with our October month. So we've got all the data we need. We've incrementally updated our pipeline, and now we're going to go through and do it one more time and do it a little bit faster this time. So I'm going to run the drop table command again, and then I'm going to let me go ahead and copy that over, dropping our bronze table so we can do the incremental load for November as well. And now I'm going to copy over the new create table statement, specifically pulling in that data from November, and I'm going to hit run. And then the next thing we're going to do is specifically do another insert from our data after validating the bronze temp table. So I'm going to insert here. We're going to skip that validation. Might be a mistake, but we're going to do it. And then we're going to hit run, and we're going to get all of those transformations inserted as expected, which should be about 200,000 rows. So we see here we've got our finished product, and we are good to go forward. If we go back to our silver transformations and we look here again, we can see our third version history incorporating those 290,000 rows. So I'm going to select from the snapshots table one more time to validate that third run. And we can see that third update for the 2 incremental updates and that 1 historical load. And if we click on those changed partitions, we can see the added records available to us as well. There's also a lot of other information that you can do. Iceberg's really, really powerful. This is just kind of the tip of it. So if you have more information in the lab guide, there is a link to a different webinar, which is all about Iceberg and goes a lot deeper of all the things that you can basically do and utilize using the Iceberg table format. And so now we're just going to validate those 2 views one more time. So I'm going to run those select statements again to validate that number's going up, validate we have more subscriptions, more subscribers, more average trip seconds different than expected, which it is. And then I also want to just check and view that the other view has specifically the dates from November. So we can see here our trip month, the average income, the hour of the day, all of the information that we need. And then one thing that we're going to do, the last step to this, is we're actually going to schedule out starting on page 37, we're going to schedule some of our jobs. So at this point, we've validated our data pipeline. We've built the incremental pipeline. It's now time to sort of harden the pipeline. This is a little bit outside of scope from our lab, but really what you would do is take your favorite transformation orchestration tool like Airflow, Dagster, Prefect, and you would essentially leverage out these tools to schedule your data. You can also use dbt Cloud. They have a scheduling feature within their cloud technology so that you can actually schedule these jobs out and build that orchestration tool so that everything happens sequentially as expected. What we're going to do is actually schedule some table maintenance for us. Because we're using these Iceberg tables that we've built in the silver layer, what we need to do is actually schedule some optimize commands and some snapshot commands so that we can actually keep our data optimized and performant in that Iceberg table. Because of the way that Iceberg works, you have the benefits of the warehouse-like capabilities on the data lake, but you need to actually also apply that table maintenance to make sure the files stay compact, to make sure it doesn't hinder performance or hinder basically the amount of files you have, slowing everything down. So we're going to create some of those jobs that you can do manually. The other thing you can do is actually just run these commands straight in the query editor, or you could use Starburst free table maintenance offer that they have available, which is linked in the lab guide. So this portion of the lab guide is going to be for anyone who just created an account or has these elevated features. If not, you can just run the execute optimize commands and the 2 expire snapshot commands in your query editor, and you'll be good to go with your table being optimized. But we're just going to schedule that job so that it can be something that we incorporate our scheduler here and show you kind of how you can start thinking about maybe scheduling via Starburst Galaxy. So the first thing we're going to do is look at our Silver files on page 37. I'm going to hit the run button, and we can see we have a lot of files from our different, incremental loads, our historical loads, all of the data that we've capitalized on throughout our data pipeline building. And now what I want to do is I want to go to the Jobs tab available here on the left-hand side, and I want to click Create SQL Job. So I am going to add the name and description available on my lab guide on page 38. And I'm just going to add this as the Blue Bike Silver Optimize, which is going to be the optimize that takes place once a month for our silver table, because we're only getting it loaded once a month anyways. So we don't need to optimize more than that. I'm going to choose my free cluster, and I'm going to choose the account admin as the executing role. And then I'm going to copy over the command that I would want run in the query. And then I'm going to click the select frequency button. I'm going to add that I want it monthly, run at 12 a.m. on the 1st. Oh, sorry. And so now I've got my new SQL job created so that this command will run on the 21st. And you might be wondering, what does that command do? I'm going to pop back to the query editor and show you. So we can see all of these files available to us. And what this optimize command is going to do is it's just going to clean it up, make it more efficient, and it's going to do all of the work on the back end for us to make these files basically more compact, clean up the smaller files, make them more performant, essentially. So it's a better performance going forward. Better performance, better scale, all of it. So if we rerun the files here, you can see we only have 4 as opposed, I think it was 6. So everything's a little bit more available to us. That was just a little side detour, a little bit more into Iceberg. But the important part is we have scheduled that job to run so that it will automatically run for us without anything coming up on an issue. And then the second scheduled job that we can do is actually schedule another SQL job to remove those expired and orphan snapshots. So I'm going to create a second SQL job named Blue Bikes Remove Snapshots. This is all on page 39 of your lab guide. And this will remove any of the old or expired snapshots that are greater than 7 days. So then I'm just going to select my free cluster again. I'm going to select the account admin as the executing role, and I'm going to copy in the queries available on page 39 and 40 of the lab guide. So let me just copy one of them over for now. You can do the expire snapshots, or you can do the orphan files, or you can do both. Got that copied over, and I'm going to select the frequency as let's do daily at 12 a.m. So this will essentially run that expire snapshots command to get rid of any snapshots that are greater than 7 days. So I can create that SQL job, something that you can also run in the query editor. So if we wanted to go back to that query editor, you can see manually running it. But the difference is between manually running it and scheduling it, there, is a lot of things that can go wrong in between. We would prefer to schedule as many jobs as we can so that you don't have any issues. And so with that, we have done incremental pipelining, historical pipelining. We've hardened our pipeline. We've created some jobs. And I think we've had a full hour and a half almost of fun. So I want to thank you so much for sticking with me. If you're still there, if you have any questions on the lab guide, I just want to say, please feel free to email me. I'm happy to jump in and go through any questions on the lab guide. I'm sure there are a bunch of questions in the chat. I have been unavailable to watch as much as I was at the beginning. because of trying to focus on the lab. But I will make sure that all of those questions, anything that has not been answered, gets answered. And again, I just want to thank you for spending your Wednesday with me, or Thursday if you're in a different time zone. So, thank you so much. And I'm going to go ahead and look at those questions. I think I see people chatting back and forth. But I know we're coming up to close to time. So if your questions did not get answered, be on the lookout for an email from me, and all of the resources that we talked about today, including the PowerPoint, the lab guide, the slides, will all be sent out so that you can watch at your leisure. And with that, I just want to say a big thank you again, and we'll chat soon. And then I'll be scrolling on I'll be scrolling in the chat, make sure all the questions get answered. So have a great day, and I'll talk to you later.